Hi guys, welcome to this webinar for the FME World Fair 2021. I'm going to take you into the world of reading and writing XML dynamically with, of course, FME. My name is Marieke Buking. I'm a consultant GeoICT for Ordina in the Netherlands. I'm a certified professional, FME certified professional and FME server certified professional. Today, I'm going to take you into the world of XML. I'm going to talk a little about the background of the project we solved, the goal of the workflow, the solution, and a little bit about XML reading and writing 2018 versus 2020, and of course, a conclusion, the takeaway. A little background, our client was ProRail. It's a Dutch maintenance company for the railways, and they wanted to convert contact wires and their associated electrical objects like insulators from AutoCAD to XML. The XML uses IMSPOR, which is an information model for rail IMX, and that's basically a predefined set of XSDs for the XML. This is a part of one of those XSDs, in this case for the railway electrification, and it shows you the structure of a phase break and some overhead line demarcation markers. So the goals for the project were to convert AutoCAD drawings to XML. Furthermore, to convert those XML to a SQL Spatial Server database, which was SG Geodatabase enabled. And to make sure that any changes to the structure of the XML were easily implemented outside of the workspace, because currently IMSPOR is still in the build-up phase. They're still making changes, adjusting the data and the attributes and such. So any changes to the structure needed to be implemented by someone who didn't know FME. So we want to make sure that they can do that without adjusting the workspace. And we were using FME 2018. So to write XML, the basis of the solution, we created XML template files to eventually use XML Fragmenter to create the XML fragment for each object type. And these files were stored as an XML file outside of the workspace. It uses the templating expression from FME, but we put it in a file outside of the workspace. So, for instance, if an object has an end time, we said, okay, if it has that attribute and it is filled, and we created the expression and put it in file. But furthermore, XML uses parents and children. It has a parent-child structure, and each object type can have several levels of parents and several levels of children, of course. So we needed to create a CSV with the structure to create the eventual XML. And here is what it looks like, the CSV. The object type on the left is basically the lowest child, and then we see the next parent and eventual children. Now, to write the XML, we created a custom transformer, and it reads in the CSV with the structure, and it reads in all the XML templates. And the XML templates have a name based on the object type it templates. So we then merge those two. So we have both the structure and the template to create the fragment. And based on the object type, we then merge it to the features coming in. So each feature has an object type, it knows what it belongs to, and then it also has an attribute with the template expression. And in the next custom transformer, you see we only have two transformers within that custom transformer. It takes a sample of one element to create the root expression, and then each sub feature uses the sub template expression, which is based on the value of the text file that we created, of the XML file template expression. And then we also need to create all the parents, and we do that in several steps to create each level of parentage. And that's eventually how we create the XML. We will dive into the add a parent to an XML fragment. And it's basically another parent add and add the fragment to a new root. And then you have a adjusted fragment. That's the basis of the XML writing phase. Now, to read XML, we use an Excel file as a translation between the schema of the database and the schema of the XML. This is done because the database uses different attribute names in some cases because of length specifications for attribute names, whereas the XML sometimes has very long names for an attribute. It cannot be created within the database. So we translated it using a schema. Here on the left you see the feature class name within the database, the geometry type, and in the third column the XML element name. So we see basically they're the same within the database part. They have a little prefix. And in some cases, some tables, because it's a relational database, we created some extra tables to store the relations that sometimes for one element, several objects have a relationship. And in an XML, that's one element with references. Whereas in the database, it needs to be several records. So we created a relationship table, but that's not an XML element. We know, though, where to extract them from. In the next tab, it's the same Excel. We see the feature class, the name of the attribute in the feature class, and the XML attribute name in the XML file. And for instance, you see the power switch ref. It has that name in the database, but in the XML file, it's a connecting overhead line power switch ref. And that name was just too long for the database. The solution in FME was once again is a custom transformer you see on the right here. But first we read in the Excel schema, and this is done to create a separate attribute with all the elements of the XML we need to read in. So first we filter on database records, XML records we want to read in. We create a list, and we then concatenate that list to one value, and those are the XML elements we want to read in. And the other input is basically all those attributes that need to be renamed. So when we take a look at the custom transformer itself, it uses a feature reader, and in that feature reader, it reads in the XML file itself, and it only reads those features that are defined in the attribute value of XML IMX. It then, from the schema, exposes the list with attributes and attribute names, and creates the object type it belongs to, explodes that list, and then creates, we filter only those attributes we want to take into the next part. because there are elements like FME attributes and other attributes that we don't need, so we don't want to take them into the next step. And we call the attribute name, that's the name we want to expose. So we call that attribute expose. In the next step, we join the schema to the features, and using an attribute manager, we create two new attributes. That's attribute name and attribute the value. And the name is based on the value within attribute expose, and the value we use to map the value of the attribute expose. So it's add value of add value attribute expose. So if we have say we have an ID with value 1, in name we get ID, and in value we get 1. And then we know, okay, this is the name the attribute needs to be given with that value. Then we only take those attributes we want to take with us in the next step, and join those to the attribute we need to rename to the database. And with an attribute pivoter, we then, based on the ID of a feature and the object type, we merge all those attributes into, instead of all being records, we create them to attributes. And the name of the attribute is then the new column, and the value of the attribute is the record value. So now we have all our features with the relevant attributes. The attributes aren't exposed yet, and we won't need to, because when writing the data, it knows it's there, and it doesn't even need to expose it. Now, in the next step, we only expose the dates, because the database uses a different format for the dates than the XML does, and if you want to write them as dates, we need to convert them. And for that, we need to expose them. Then we filter those objects that have an end date, because we deal with them differently. The record already exists in the database. We just need to give them an end time. But for the new objects, we filter based on geometry. We only have points, lines, and tables. So tables have no geometry. But for the points and the lines, we create the geometry based on the attributes with the GML fragment. And that's what you see in the lowest section. Now, I talked a little bit about FME 2018. We created this solution in FME 2018 because that was what they had at the time. And in FME 2020, a new XSD-driven XML reader was made available. This was the first time that an XML reader was XSD-driven. So I wanted to compare the two. The pros, the XSD-driven XML reader uses feature path to select feature types. So it becomes easier to select the correct feature types and then have the structure made available to you. The cons, it's not automatically dynamic. So if you have a new feature path, it doesn't automatically is made available within the output. And parent element, if you use a parent element as a feature path, it still means that you need to build a process and workflow to make available the correct attributes within the children. So I would use it for XMLs that have a static schema, or for XMLs that have a simple structure. But otherwise, if the structure continually changes, I wouldn't use it that much. FME 2020 also had a new XML writer based on a schema, and it's very useful when creating an XML with a simple structure. I did find it difficult to find how to use the dynamic writing possibilities. And optional elements were output as empty strings. And in some cases, that means the XML isn't valid. So that wasn't always the correct way to go. And in one case, I had a writer with 4 feature types, and I wanted to create an XML with those 4 feature types, but only 1 feature type was written. So maybe I need to do some more experimenting. But my takeaway, for the moment, I'd still rather use my dynamic way of creating an XML that I used for this particular project, because it's dynamic. It's expandable with new object types or with changing attributes. And it's easily changed when the schema has been changed outside of the actual workspace, which means someone without knowledge of FME can actually implement the changes that are made within the schema for IAMS4. So it's a dynamic solution. The changes in deleting or renaming of object types and attribute names don't need to be implemented in the database or the workspace. You can just change the schema, change the template, and you're done. Which means when adding object types or attributes, the structure in the database needs to be adjusted because you need to create a new attribute for the element. But the workspace doesn't need any work. And the logic for creating the XML fragments is done outside of the workspace, which means, once again, someone without knowledge of FME can actually implement the changes in the structure. It makes it more manageable. That was my presentation for today. Thank you for listening, and I hope to see you soon in the Q&A.